By 2026, AI writes a huge share of the world's code. Not experimental code, not prototype code. Code that ships to users. Code that handles payments, authentications, user data. Code that runs in production right now at companies you've heard of. And most of it is unreviewed. That's not an opinion. That's the default state of vibe coding, prompt-driven development, where a developer describes what they want in plain language, and a tool like Cloud Code, Cursor, or Lovable, or whatever generates the code, the config, and sometimes the whole app. The developer's role shifts from author to director, which is powerful, and which also removes the friction, the grinding, the reviewing, the arguing that traditionally cause security and design flaws before they reach your users. So the question every engineering leader is asking right now is, can we trust this code in production? Here's the honest answer: yes, but only with guardrails. And the data and what happens without those guardrails is sobering enough that we build an entire episode around it. Today, I'm joined by Emmanuel, senior software engineer at MagmaLabs, who has been working with AI-assisted development in production environments. Together, we're going to cover three things: what the data actually says about AI-generated code, why vibe-coded apps fall in production, and the four parents that show up again and again, and the specific pipeline that makes vibe-coded production safe without killing the speed that makes it valuable. By the end of this episode, you'll have a concrete answer, not a philosophical one, to whether vibe coding belongs in your production environment. This is the Scaling Dilemma. So, Emmanuel, you work with AI-generated code regularly, right? So, before we get into the numbers, I want to ask you something that might sound kind of like basic. The question is this: when a developer uses Cloud Code or Cursor or whatever, right, and ships what it produces, what are they really shipping? What does the code look like from the inside?
Well, basically, they're shipping synthetically functional code that is architecturally blind. The AI is trained to optimize for the happy path. It writes code that satisfies the test suite and passes the compiler, but it
Mhm.
has zero context regarding the broader system architecture. For example, I seen AI generate a robust, perfectly formatted API endpoint for
Mhm.
saving user profiles. It handles the JSON parsing and database insertion beautifully, but it completely ignores the authorization context. The code works, it runs, and it passes unit test, but it effectively allows any authenticated user to overwrite any other user's profile because the logic for does this user own this resource simply wasn't requested or contextually inferred. They aren't shipping features, they are shipping logical skeletons
Yeah.
that are dangerously missing the muscle of the business security.
Okay, so Emmanuel, I'm going to present you some data that I found. Right, the data from independent security research is stark, is rigorous. Right, roughly 48% of AI generated code ships with a known vulnerability. That's one of the data. Right, the second is 86 failed SQL injection tests, and there is a 37 increase in vulnerabilities after AI coding tools are introduced to the team, right? So the question is this: when you see these numbers, I mean, do they match with what you've seen in practice?
Well, honestly, those numbers feels conservative.
Mhm.
The most common vulnerability isn't the spaghetti code people fear.
Okay.
It's the logical omission. The AI defaults to insecure configuration because that's the path. For instance, a standard security scanner might pass a block of code, but it won't catch an insecure direct object reference. The AI assumes that if a user is logged in, they have permission to access that object. It doesn't inherently understand your specific business constraints on data ownership. You end up with code that looks professionally written,
Mhm.
passes a standard linting, but is structurally wide open.
Okay. Okay. So the numbers are real, and Emmanuel just confirmed it from the ground level. But here's what I want you to notice about those numbers. They're not surprising if you understand what AI is actually optimizing for. AI coding tools optimize for code that runs, not code that is secure, not code that is maintainable, not code that a human can explain 6 months from now. Code that runs. And the gap between functional and safe is exactly where the vulnerabilities live. Georgia's Tech Vibe Security Radar Tracker CVEs attributed to AI-generated code climbing sharply through 2026. A large scan of thousands of deployed vibe-coded apps serves thousands of critical vulnerabilities, hundreds of exposed secrets, and real PII left in the open. The problem isn't one bad line of code, the problem is scale. AI lowers the cost of producing code so dramatically that volume and speed outrun the review, ownership, and policy controls meant to govern it. That's not a technology problem, that's a process problem. And process problems have process solutions. But first, we need to understand exactly how vibe-coded apps fail. Because the four failure modes that show up again and again aren't random. They are predictable. And if you know what to look for, you can build the war rails before the incident, not after. In the next part of our talk, Emmanuel walks us through what those failure modes look like from the inside. The post identifies for failure patterns that show consistently across independent studies of AI generated code, right? So hard coded secrets, broken access control, hallucinate dependencies, and no owner. Well, that means no review. So Emma, from your experience, which of these do you see most often, and what does it actually look like when it happens?
Yeah, broken access control is the silent assassin. It happens constantly when generating services. You ask for a service to handle invoice processing, for example, and the AI gives you a controller that perfectly calculates the totals and writes to the database. It works perfectly, but the check to ensure the user requesting the invoice is actually the owner of that invoice is usually absent. Uh, if the developer doesn't explicitly add that guardrail, the AI won't. It assumes the client side frontend is always sending the right data to the right place. It's dangerous because the code looks so clean that it passes the security it actually deserves during review.
Okay. Next question. In February 2024, Moldbook, this social platform built entirely through vibe coding, made security news when researchers found that a misconfigured database exposed all over the internet, right? So 1.5 million authentication tokens, 35,000 email addresses. And the root cause wasn't a sophisticated hack, right? It was AI scaffolded infrastructure deployed without a security review. That's what we were talking behind scenes, right? So
Yeah.
that's the case. Does the case surprise you? Does this case surprise you? Have you seen similar situations?
Well, not in the slightest. It's the logical endpoint of a process that prioritizes deployment success over security hardening. When you use AI to spin up a cloud infrastructure like Terraform or CloudFormation, for example, its primary object is to make sure the script runs and the infrastructure is reachable. By default, it set up the public faces by default, it set up public facing databases and
Hmm.
open security groups because that's the easiest way to ensure the script doesn't fail at runtime. The AI doesn't know that the database should be in a private VPC, for example, or that it requires IAM role isolation, for example. In this case, Moldbook wasn't a mistake.
Yeah.
It was the machine doing exactly what it was optimized to do: minimize friction and maximize uptime regardless of the security cost.
Okay. Okay. So there is a concept in the blog post, right, called comprehension debt. So I'm really aware of what is a technical debt, right? But now comprehension, that is a different situation. The idea that when AI generates code fast and human merges it without fully understanding, right? It's like, please, computer, do this and do that, right? And you don't know how this thing is doing, right? So it's like going in autopilot instead of co-pilot, right? So this is how you accumulate that, not just in technical quality, but in human understanding of your whole system. So the question is, how real is that in practice? I mean, what happens to a team 6 months in?
Well, comprehension depth is the interest rate you pay on the velocity you gain in week one, for example.
Hmm.
It's very real. It's very real. 6 months later,
Hmm.
you have a system full of magic code, blocks of logic that works perfectly, but
Yeah.
were generated by an AI in a prompt session that no
Yeah.
longer exists in
Uh-huh.
anyone's memory.
Yeah. Yeah.
No, so when that code inevitably breaks or
Uh,
needs a nuance business rule
uh-huh.
change or
Uh-huh.
something like that, the team doesn't know why the AI choose that specific library
Yeah.
or that specific async parent, for example.
Yeah.
So we end up spending 3 times as long trying to reverse engineering the AI's logic as it would have taken to write it manually from the start.
Yeah.
It
Yeah.
kills team confidence and
Uh-huh.
creates a "don't touch it, it
Uh-huh.
works"
Yeah. Yeah.
culture,
Yeah.
which is the death of any product.
Yeah, yeah, exactly. I mean, this is an analogy, right? But I don't know. You got a teenager kid, right?
Yeah, yeah.
Yeah. So isn't it fun, like when you driving him around to his chores or whatever, right? Soccer practice or school or whatever, and then you ask him like, "Okay, you can go by yourself because you know I have already taken to you." He doesn't know how does he get here, right? It's like, I don't know. I get lost in the city,
The
right?
AI does. The AI
Exactly.
did it.
Yeah, exactly, right. So it's like driving backseat and taking a nap while the
Yeah,
AI takes you there, right?
yeah, yeah.
It's like that. Oh my god. Yeah. Okay. So we have the failure modes and we have the mechanism that produces them. AI optimizes for code that runs. Volume outpaces review. Comprehension that accumulates. And somewhere between the first sprint and the 6 months, you have a system that works until it doesn't. And nobody on your team can explain why. But here's what the post says that I want to highlight. None of these risks are new, and the fixes are well understood. The goal isn't to slow down, the goal is to reintroduce just enough friction to govern speed, without killing it, of course. That's the key phrase. Just enough friction. Not a return to waterfall. Not a 48-hour code review process. Not a security audit that takes longer than the sprint it's auditing. A pipeline. 5 stages. Each one adds a small automatable check. Together, they turn prototypes into production-grade software. And the highest leverage habits in that pipeline are surprisingly simple. Treat AI code as untrusted by default. Read it, test it, run a static analysis before it merges. Mandate human review and clear ownership. Every AI generated change needs a person who can explain and maintain it. Automate the boring board rails, real-time secret detections, dependency checks, CI/CD security gates, prompt for secure defaults. A single line like use parameterized queries and validate all inputs goes a long way. And reserve manual coding for critical paths, authentication, payments, permission, everything stays under human control. Next, Emmanuel tells us what the pipeline looks like when you actually implement it and what changes in a team when you do. The post describes production safe pipeline, right? A production safe pipeline. Generate, human review, automated scan, staging, right? Deploy with war rails. Can you walk me through what it looks like in practice at a team level? I mean, not the ideal version, but the version that actually works when developers are under a deadline pressure.
Well, a pipeline that works under pressure isn't the
Uh-huh.
ideal one. It's
Okay.
the one with hard, non negotiable gates. First, we treat AI generated code with more skepticism, not less.
Okay.
Um, Number one, automating the static analysis as a hard stop. If the code doesn't pass the security linter, the PR is physically locked from merging. No exceptions for deadlines.
Yeah.
Number two, context aware human review. We force a manual review specifically for access control patterns, as we been mentioned before.
Yeah.
Um, Number three, the why requirement. For example, the developer merging the code must be able to explain the logic in 30 seconds. If they can't, it doesn't get merged. That's it. Number four, the biggest failure point is skipping the review under pressure. The discipline comes from making it possible to skip. If the automated gate is automated, you can bypass it, no matter how much the deadline is looming.
Yeah. The post says to reserve manual coding for critical paths, right? Authentication, payment, permission, right? So, where do you draw that line in practice? I mean, how do you decide what AI can touch and what it can't? Okay.
My rule is simple. If the code touches a state, meaning a database, an authentication token, or external permission policy, it is human written territory. So AI is phenomenal at boilerplate, unit test,
Hmm.
documentation, DTO structures, and standard crude boilerplate. But the moment the code interacts with the ground rules of the system,
Hmm.
data persistence or authorization, the AI is banned from the keyboard. Before I let the developer push AI generated code, I ask, can you explain the security implication of this line in 30 seconds? If the answer is, I don't know, the AI generated, then it's not production ready.
Okay. So something else that I saw in the blog post, right? So it was kind of like a reframe. It says something like, "Is vibe coding safe for production?" That's not the real question. That's what the blog post said, right? So the better question to be asked is whether your process can catch what AI gets wrong,
Yeah.
and at that speed AI introduces it, right? So from where you sit as a senior software engineer, what does a team that's gotten this thing right actually look like? Like, what's the difference about how they work?
Well, they treat the AI not as a partner, but as an untrustworthy junior intern.
Hmm.
Um, Radical skepticism. The best teams review AI code assuming it's wrong, looking for the security hole rather than looking for a fix. Ownership. They never use the excuse the AI wrote it.
Yeah.
Every developer is 100% accountable for every line in their PR, regardless of its origin. I don't care from if comes from code or come from other AI tool. Architecture first. These teams discuss the architecture and the data flow before they open the IDE. They
Yeah.
have realized that the speed doesn't come from typing faster. It comes from having an architecture so clean that the AI only has to fill in the boring parts.
Okay. Okay. The bottom line from the post and from this conversation with Emmanuel is this. The question, is Vive coding safe for production, is the wrong question. It's a wrong question because it frames Vive coding as binary, safe or unsafe, when the real variable is your process. Raw, unreviewed Vive coding is not production safe. The data is clear on that. 45% of AI-generated code with known vulnerabilities, 86% fail in SQL injection tests, a 37% increase in vulnerabilities after AI tools are introduced without more rails. But with human review, automated security scanning, clear ownership, and the discipline to keep critical paths, authentication, payments, permission under human control, well, AI-assisted development can absolutely run in production. The danger is in the AI. It's shipping its output without the checks you'd apply to any other code. And that, the checks, is what separates the teams that are going to win in 2026 from the ones that are going to make security news. The teams that win won't be the ones vibe coding the fastest. They'll be the ones pairing AI speed with discipline review, security, and ownership. That combination is what Emmanuel described today, and it's what MagmaLabs is built for, helping engineering teams put the right review, security, and governance around AI-generated code. So speed never becomes a liability. If you want to see that in action, the link to explore our work is in the description. I'm Darwin, and this is The Scaling Dilemma.